session. We begin with blood. It is made up of plasma plus cells. We have plasma and cells. Cells further consist of three types, three major categories. We have got erythrocytes. These are also called red blood cells or RBCs. We have got the leukocytes. Those are called white blood cells, and thrombocytes. These are also called platelets. So we've got erythrocytes, red blood cells, leukocytes, and thrombocytes. Firstly, we begin with erythrocytes. Erythro word means red. Erythro, that means red. That is why they are called RBCs or red blood cells. Now the important features you have to know about RBCs is these are biconcave. What do we mean by biconcave? And why they are biconcave? They're somewhat like this. They're narrow in the middle and broader at the sides. So concave from this side, concave from this side. Upper side also concave, lower side also concave. This is the cut section. Of course, otherwise they will be round, somewhat like this. And they will be having the broader border and a very narrow core relatively. Somewhat like this. So in the middle, they are narrower, and at the edges they are broad. That is what biconcave means. Why they are biconcave? Because they have no nucleus. The most bulging organelle in the center for cells is nucleus. They don't have nucleus, so the central bulge is not there. They also lack mitochondria. They also don't have any mitochondria. Why? Because mitochondria is the site of oxidative phosphorylation, which means oxygen is used here in mitochondria. So whichever oxygen we inhale with every breath, it is used in mitochondria for oxidation of food in our body. Now, the job of RBCs is to transport oxygen. So nature has created them in a way that they themselves don't use oxygen. They just transport it. So they themselves will not have any mitochondria so that they can use oxygen. So they will just transport oxygen. I hope that's fine with everyone. Then another important feature is their lifespan. Lifespan is 120 days. They are formed, all blood cells including RBCs, they are formed in bone marrow, and destroyed the older worn out RBCs. They are destroyed in spleen. Sometimes they ask you which of these is called graveyard of RBCs. Remember, spleen is called graveyard of the blood cells or RBCs. Their count, their normal count it is 3.5 to 5.5 million per millimeter cube. That is for females. Whereas 4.2 to 5.6 million per millimeter cube for males. So males have relatively higher number of RBCs. Higher count in RBCs in males, that is due to testosterone level. Effect of androgens. Higher count in males is due to androgens. Then another way to observe the count is hematocrit. Either we'll go for the actual cell count or we can go for the hematocrit. What is hematocrit? I'll show you a picture. Can everyone see the screen again? So this is the test tube. What is hematocrit? What they do is they take a sample of blood, put it in a test tube and allow it to stand for some time. Cells being heavier, they will start settling down, and on the top you will just have plasma. So all RBCs have got settled down. Since RBCs are red in color and they are responsible for the red color of the plasma, the lower part of the test tube will look red. The red column indicates the count of RBCs. And on the top you will have pale yellow clear fluid which is called plasma. In between the two, sometimes a clear line is visible, sometimes it is not distinguishable, sometimes it is visible. That is a small zone for white blood cells. White blood cells are quite less in count as compared to, those are just 7,000 to 11,000 in a normal person. And you You can imagine that RBCs are in millions. So white blood cell layer will be very small as compared to the red column. So it is not even distinguishable. And platelets are very small. So they and WBCs, they exist kind of together. Now, if this red column is very tall, like let's say up till here, it is all red. That means we have got a lot of red blood cells. But if this red column, its length come out to be lesser, let's say it's just up till here, that means the RBC count is lesser. So we just measure the total length, and out of the total length, how much is the length of red column? That will directly give us an indication about the number of red blood cells, right? This is called hematocrit. And remember that hematocrit value, it is 36 to 46% in women and 41 to 53% in men. That means if it is total 10 centimeter long test tube, out of which 3.6 to 4.6 centimeters should be the red length. And in males, 4.1 to 5.3 centimeters should be the red length. That is what the hematocrit is. Average for both, you can say it is 42. So it should be around 40, 42, which will be considered normal for both males and females. Now we have done that the red blood cells, they don't have any mitochondria. If red blood cells don't have mitochondria, that means they cannot do the oxidative phosphorylation, which indirectly means that they do anaerobic respiration. So red blood cells are the cells which transport oxygen, but they themselves rely upon anaerobic metabolism. They rely upon anaerobic means. Then there is a disease in which RBCs, their shape become distorted. Diseases will do in pathology, but you know that the RBCs become sickle shaped. That is called sickle cell anemia. Why anemia occurs when RBC becomes sickle shaped? Because the biconcave RBCs, they can easily bend and pass through narrow capillaries, but when they become sickle shaped, they're not able to pass through the narrow capillaries. They get stuck, and those are abnormal. So the spleen will destroy more of RBCs because its job of spleen to destroy the old worn out abnormal cells. Since the sickle cells, they are abnormal, spleen will destroy them more, and the person will end up in anemia. Is that clear? Now, job of RBCs, you know their job is to transport oxygen, and the oxygen transporting pigment, they have hemoglobin. Hemoglobin can bind with oxygen to form oxyhemoglobin. All that you know already. Then coming to the leukocytes. Leukocytes, these are also called white blood cells. They are of two types, granulocytes and agranulocytes. Granulocytes, these are neutrophils, eosinophils, and basophils. And they're called granulocytes because they've got some granules in their cytoplasm. Whereas agranulocytes, those are lymphocytes and monocytes. Details of these white blood cells you will study after microbiology. We do the immunology or the immunity. There we do the details of all these immune cells and how immunity functions, but we'll go over their basic features. Firstly, neutrophils. Neutrophils, also called PMNs, that means polymorphonuclear cells. Polymorphonuclear cells. These contain granules. These contain granules which contain peroxidases. Peroxidases, example, myeloperoxidase. These enzymes, they do the peroxidation reaction and they produce nascent oxygen. Nascent oxygen is very toxic for the cells, so the cells are destroyed. These are first cells to reach the site of inflammation, so they are cells of acute inflammation. Cells of acute inflammation because these are first cells to reach the site of inflammation. They kill the microbe with help of this enzyme, and then they do the phagocytosis. Phagocytosis is they engulf the microbe, and after engulfing they kill the microbe with help of peroxidases. So what kind of enzyme is present in neutrophils which kill the microbe? That is very important. Peroxidases, or the name myeloperoxidase, that is quite important. Then coming to eosinophils. Eosinophils are bilobed. Bilobe nucleus, and these take part in allergic reactions and parasitic infections. These are quite less in count, 1 to 3% only out of the total WBCs, whereas your neutrophils, these are about 60 to 65% of total WBCs. So neutrophils are one of the major inflammatory cells. Eosinophils relatively are quite less. And then basophils, they're even lesser. These are just 0 to 1%. They release histamine. Histamine is a very potent vasodilator and is released in inflammation. Basophil, they become mast cells and settle in tissues. So this is very important exam question. Histamine is released by which cells, and usually the option is mast cells. But remember, mast cells are derived from basophils. So basophils also release histamine. Mostly you know that the mast cells release histamine. But the basophils also release histamine. There is agranulocytes. Agranulocytes, first is lymphocytes. Lymphocytes, they work majorly in viral infections. This you can write as a side note. Remember, in bacterial infections, Neutrophil count rises. In parasitic infections and allergic reactions, eosinophil count rises. Whereas in viral infections, the lymphocyte count rises. Lymphocytes, you know, they are of two types, B lymphocytes and T lymphocytes. B cells and T cells. Their function in detail will be done in immunity, but just remember that B cells take part in humoral immunity. That is, they produce antibodies. They produce antibodies against antigen. Whereas T lymphocytes, they take part in cell-mediated immunity. This is the difference between the two. B cells take part in humoral immunity, whereas T cells, they take part in cell-mediated immunity. Then we have got monocytes. Monocytes are the largest blood cells. These are largest in size. Their function is phagocytosis. They become macrophages. Just like we did basophils, they later on become mast cells. So these also become macrophages and go in tissues. They, they settle in tissues as macrophages. Various macrophages have got various names. For example, macrophages of liver, these are all exam questions. Macrophages of liver, they are called Kupffer cells. Macrophages of bone, these are called osteoclast. Macrophages of skin or of dermis, they're called histocytes. Macrophages of lungs, these are called dust cells. So these few names you have to remember. Macrophages of what area is called what, especially macrophages of liver are called what. That is important exam point. Then we've got platelets. Platelets, their precursor cells are called megakaryocytes. These megakaryocytes, they split into about 1000 cytoplasmic fragments. Let's say this is one megakaryocyte, one cell. It will split into small, about 1000 fragments. Each of these fragments is called platelet. So platelets, they don't have any mitochondria, they don't have any nucleus, they are fragments of one cell, and these are just small cytoplasm surrounded by membrane. These are very small. Their count is about 1.5 to 4 lakhs. Which is also called 150,000 to 400,000 per millimeter cube. And their lifespan is about 10 days. And their job is coagulation. Their job is coagulation of blood. So hemostasis. Hemostasis is their function. Then we've got plasma. Plasma is just the fluid, but it contains a lot of things. Dissolved in it, all the sodium, potassium, chloride, glucose, amino acids, vitamins, whatever we eat that is transported by blood, that is all dissolved in plasma. Major thing we have in plasma is plasma proteins. Most abundant is albumin. Other plasma proteins are globulin, immunoglobulins, etc. For example, even fibrinogen, that is involved in clotting process, that we'll study in physiology part. Then you must know that hemopoiesis process, hemopoiesis means formation of blood. That takes place in bone marrow. and the worn out old blood cells or abnormal blood cells, they're removed by the spleen. You need not go into the details of hemopoiesis. And also remember that the lymphocytes, they live inside lymph nodes. You must have observed or studied that in infections there is swelling of lymph nodes, or we palpate lymph nodes to check whether there is some problem or not. Remember we did lymphadenopathy happens in this viral infection. So lymph nodes of that area where the infection is, the lymph nodes of that area become inflamed, infected and swollen. Why? Because the B lymphocytes living in those lymph nodes, they become hyperfunctional. So lymphocytes, some of them they're in blood, but most of them they're residing inside the lymph nodes. And remember, we'll do that in immunity part also. B lymphocytes, they're formed in bone marrow and they undergo maturation also in bone marrow. Whereas T lymphocytes, they're formed in bone marrow but they undergo maturation in thymus. Formed in bone marrow but maturation takes place in thymus. Is that clear? That's all about your blood cells and plasma, but this is not all, because platelets and their function in detail, the whole clotting process we'll be doing tomorrow, that is blood physiology. And then the white blood cells and their functions in detail, the immunoglobulins, etc., those we will be doing in immunity part. Okay. Mariam, you have done the head and neck, right? Head and neck and dental anatomy. This is the last thing. The systems are last thing which you're left with, right? Yeah. Okay. After you have your baby, I have another morning class going on. I mean, that will be night for you. So you can join that anytime if you want revision. Okay. Things are still going on there. Okay, we stop here. Um, Tomorrow we'll be doing blood physiology, which is majorly the clotting process. Bye everyone. Bye for now. See you guys tomorrow.